Did you know that Console.log can do much more than just simple string logging? For example, you can use %d in your first argument of the Console.log function to tell JavaScript that you want to substitute this value with the argument you pass in at the second position. But sadly, the typings of Console.log do not show us a compile time error when we provide a wrong substitute for our placeholder. For example, when we pass in a string instead of a number. We only see this then when we get not a number in our Console.log statement. So wouldn't it be nice if there was a proper Console.log typing which would show you at compile time in your TypeScript code if you provide a wrongly typed substitute for this placeholder? Well, in this video we will do exactly that. We will create our own Console.log typing which will show you immediately if you provide a wrongly typed value for your placeholder. Let's get started. So before we start to implement our type, let's see what the current issue really is. So we have this Console.log here, and we have this %d and this %s. And Console.log will replace these values with the arguments we pass in. It will replace this %d with a 5 and this %s with the typed. So when I run this and I use tsx console.log.ts and I run this, we see we get high 5 type rocks something. Now this something here still gets printed out because even if it's not a replacement for anything, because we can just add as many arguments additionally in our Console.log as we want. Now what's the issue when I, for example, change this and I remove this 5 here? When I now run this again, we see I get high, not a number, something rocks. Because JavaScript tries to parse this typed here into a number, and because this is not a number, we get an issue here at runtime. So we want to make sure that this is no longer the case. But the issue we have is, of course, this log function here does only have the typing that the message has to be of type any, and you have any optional params. So there is no proper typing. So after we've created our type, we will have the following. We will have a log function here, which takes a message of type t, but additionally, we will then have all the proper typings for our replacement arguments. So we will have param 1, which has to be a number, param 2, which has to be a string, and then of course we are allowed to pass any arguments we want after that. So when we have provided everything we need for our percentage replacements, then after that we can pass in anything we like. So let's get started with the implementation. So before we can start to implement the real type, we have to create some helper types. So for all of you who are not interested in seeing how these work, you just can click on the next timestamp in the video and we will see us there when we implement the real type. But for all the other ones, let's get started. So the first helper type is a mapping type. So the key of this mapping type will be all the characters we will replace with a type. So for example, this D we replace with a number, this S we replace with a string, and so on. So we use a type and we say mapping here, and we could now say we have for our D, we will say number, and for an I, we also have number, and so on. But we can make this much more concise. We can say we have a key in, and then we say either D or I or F, and then we don't have to add the number for each possible character. So let's remove this again, and we can now add an intersection type, and we say if we pass in the character S, we want to replace this with a string. And also when we pass a lower or uppercase O in there, we want to replace it with an object. So we say key in O or uppercase O, in this case, return an object. And now we have already created this mapping type. So when I have this type here test and I say mapping and I pass in D, for example, then we will see we will get back the number. So we will use this later, but let's now create another helper type, because to create this param 1, param 2, and so on, we need to create a tuple. So we need to have a tuple which has a number in there and a string in there in this case. So the number is the first argument and the string is the second argument. And to create such a tuple, we'll create the helper type add mapped to array. So let's first remove this test type and create this new type add mapped to array. So the first argument we pass in is our args array, and this args array contains the already existing arguments. So for example, if we have already added our first argument, then this array will already contain it. So we say this extends in any array, and as a second argument, we pass in our character. Now this character is the one we want to check if there is something available to replace. So for example, this D here or this S. So we check if this character we pass in extends key of mapping. So if this character is the same as any key of our mapping type. In this case, we create a new array, spread our existing elements from our args array into it, and then we add the value from this mapping type. So we say mapping, and we access the value from this character. So for example, when we pass in D, I, or F, then we'll add a number. Now, if this character is not a key of mapping, in this case, we will just return our args array as it is, because we are not interested. Because it could always be the case that we pass in a character which has no replacement in a real type, so then we don't want to do anything with it. So we're almost done with the helper types. Let's create the last one, and we call this type first character. This first character takes a string as an input, and it takes the first character in this string and returns it. We will see later why we use this. So we say if this t extends, and now we use backticks to have template literals, and we say if there is a first element in there, so if there is anything in the string and the string is not empty, then we want to save the first character in this head variable here, and the remaining part is just the string. I already did a video about infer. You can find it in the info box and in the description below. And this just means that it saves the first character in this head variable, and the remaining part is just not interesting for us and will just be left as it is. So if this is the case, if the string we pass in has an element, we will return the head. Otherwise, we return t itself, because in this case, it will just be an empty string. So we have now created all the helper types. So let's now get started with the real implementation. So let's first close this terminal here, and let's now create our final type. So we call this type args from placeholder. Now, what do we pass in here? The first thing we pass in here is our remaining string. So the string we still want to parse. So we call this remaining string, and we say this has to be of type string. The second argument we pass in is our collector array, which collects all these arguments and will then create such a tuple, which in our case contains a number and a string. So we call this args array, and we say this extends in any array, and we say we start with an empty array so that we don't have to pass in an empty array every time we start fresh and without any elements in it. So how will we now implement this? Let's think about this. At first, for example here, we just pass in our complete string type. Then we will check, is the first letter here, is this a percentage? If not, we will just go on and on and on. And as soon as we find something which is a percentage, then we will check what's the next character. So if this D here then is a character we want to replace, we will add one element to our args array. Otherwise, we will just go on until our string is empty. So this is exactly what we do here. So we say if our remaining string extends, and now we do the same as we did here with the infer head, but we're also interested in the tail. So we say infer head and infer tail. And what this does is exactly the same. It just stores the first character in the head and the remaining part of the string in the tail. So in this case, when this is true, when we have a head and a tail, we want to check if the head is a percentage. So we say head extends percentage. So in this case, we are interested in the next character here. For example, here in this D we have. So when this head here extends percentage, we just call args from placeholder again, and we call it with the tail. So why do we want to use the tail here? Because we are no longer interested in the head. We just want to do this for the remaining part of our string. When we would call this with the whole remaining string, this would be an endless loop, because we would never reach the end of our string. So we have this tail here, and what we then will do is we will call our helper type add mapped to array. And what we will pass in there is, of course, our existing args array with the existing elements we have. And additionally, we will take the first character of our tail, because the head here is currently our percentage here, and the remaining part, our tail, is currently this D followed by this remaining string. But we are only interested in this first character here. So what we do is we call first character, and we pass in our tail here, because this first character type here will extract the head of our remaining string. So this is it for the if case. So if this head extends the percentage, then we will call again in our args from placeholder, and will possibly add another element to our array. Otherwise, if this is not a percentage, then we are not interested in it at all. So we call args from placeholder with our tail, and we will just pass our existing args array. Because when we don't have a percentage in front of our character, then we of course don't want to replace anything. So we are almost there. The only thing missing is we have to also add the case for when we are done. So when there is nothing more in there in our string, when we are at the end, then we want to return our args array. So how do we do this? We create a new array, spread our existing args array into it. And now the important thing is that we also do the following, that we say we also spread an array in there, which is of type any. Because here we also want to allow that we have this args of type any additionally to our replacements. Otherwise, this would not be allowed. If we would only use our args array, we would not be allowed to pass in additional properties in our console.log. Now we are done with this. Now before we can implement this console.log type, we also have to do two more helper types here. The first helper type is called base types. So what will these base types contain? This will contain all possible primitives of TypeScript, which we are allowed to pass to this log function. So this will have string in it, or number, or object, or big int, or boolean, or symbol, or null, or undefined. Now you think, well, these are not really primitives, right? Because this is an object. But for TypeScript, these are like their primitive types. So this means this is like the base type of an object. So we are allowed to pass any kind of object because, for example, when you pass in a date or something else, then this is always of type object. So we need these base types to make our console.log work properly with our strings we pass in and show us proper compile time warnings, because otherwise it will not work properly, and I will show you right away when we implement the console.log. So what we also do here is we create a small wrapper around our args array. So we create this type here, optional params, and we pass in our input. Now in case where this input we pass in, and this is the first argument of our console.log call, if this is a string, then we use args from placeholder and we pass in our input. Otherwise we use an any array. Because when the input we pass in our console.log here as a first argument is not a string, then we will not replace anything and we will just allow anything to be passed in as arguments there. So we are now finally done with all the type preparation. So let's now create the proper console.log type. So how do we create this? We declare a variable here and we call this variable console. Now the type of this variable is also console, because this console variable, when we check this out, this is the interface which contains assert, clear, count, and all the other function declarations from our console calls. So for example, we can see here we have debug in there, we have dir in there, error, group, and so on. And of course, we also have log in there. So we need to override this log declaration. So how do we do this? We use this console here and we say omit, and we wrap our console type with this, and we say we don't want to have the log type. So we erase the type declaration for this log function and we will create this ourselves. So we will add an intersection type here and we will create now this log declaration. So we have this log, and we say this log function is a generic function. So we say this takes a t and extends base types. Now as properties, it takes a message, which is optional and is of type t. And as the next arguments, we have our spreaded optional params here, which are of type optional params, which take this type t. Now the only thing missing is we have to say we return void, because log does never return anything, and we are done with our console.log declaration. Now let's see if this is working. So let's scroll up here. And we can see here we already get an error here. So let's just cut this and let's move this down here so that we have it right beside our console.log declaration. So we can see here we get an error here for typed. When I hover over this, we can see that argument of type string is not assignable to parameter of type number. Now, when I hover over this log, we can see that this now takes this message, and we can see it takes an optional params 0 of type number and an optional params 1 of type string, and it allows any possible arguments after that. So let's see if this works if I add the proper type. So I add a 5 in there, and as you can see now, we don't get an error anymore because this %d is now a number. Now what happens if I, for example, here instead of typed, I write in a 1? We can see I get an error again because this number here is not a string. So as you can see, this works perfectly fine. If I change this back here, we can see our code compiles again. And as you can see, we can add as many arguments here after our replacement arguments as we want. So I can add an object here, I can add a true here, for example, and so on. So this is not restricted at all, but we are only restricted to have the proper replacements here for our %d and %s. Now, sometimes you maybe don't want to replace this %d and %s. You just want them as they are. So when we would remove this of course would no longer work because we need to replace them. So to fix this, we can just use the any type here to tell TypeScript, Please, in this case, don't do the type check, because now we pass in for this t the any type, and this optional params here, as we've stated, only checks the args from placeholder when we pass in a string. Now, I've told you that I will show you why we need these base types. So let's see what happens when I remove this any here, and when I also remove this extends base types here. When I remove this, you can see that I no longer get an error, because somehow TypeScript in this case has no way of knowing if we put in a string or not. So we always have to put in these base types to help TypeScript to figure out the typings for us. Now, of course, you can still pass in anything other you like. For example, if you pass in a 1, this will just work. You can pass also in anything other, because as long as you don't put in a string here which has any percentages which have to be replaced, this works exactly the same. So of course you can't just do this for log. You could also say I want to remove log or error here, and I want to do the same here also for error. And of course you are not restricted to console here. You can also do this with your own types. When you have your own log function and you want to have this replacement in there, you of course also can use this type. Now I think with this approach, we have a really simple way of making our console log much more powerful, so that TypeScript can help us print our console logs, errors, and so on in the proper way. So thank you for watching the video. I hope you learned something useful today. As always, you can find the link to the GitHub with the code in the description below. And if you enjoyed the video, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. And also let me know in the comments what kind of topics you'd like to have covered in future videos. See you in the next one. Bye.